Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of polynomial functions. So as per the problem, graph a polynomial function that satisfies each description. And we are given these four polynomial functions. So let's start with part A. A quartic function with a negative leading coefficient and 3 x-intercepts. A quartic function is one whose degree is 4 and this function has a negative leading coefficient. That means the end behavior of this function is from quadrant 3 to quadrant 4. This is a very important concept we need to understand to solve this type of problem. And we are also given that this function has 3 x-intercepts. The degree of this function is 4 and it has 3 x-intercepts. That means the order or the multiplicity of one of the x-intercepts is equal to 2. This is a very important concept we need to understand to solve this type of problem. Let's assume the x-intercepts are at -3, -1, and 2. The end behavior for this graph can be shown like this. Now we have to join these end behaviors through these x-intercepts. So for one of the x-intercept, the order or the multiplicity is equal to 2. That means the graph will bounce back from that x-intercept. Let's assume the order or the multiplicity is 2 for the x-intercept -3. So we can show the graph like this. So this can be a possible graph for the function a. So we are done with part A. Now we can answer part B. A cubic function with a positive leading coefficient and 2 x-intercepts. A cubic function has degree equal to 3. The leading coefficient is positive. That means the end behavior for this function is from quadrant 3 to quadrant 1. This function has 2 x-intercepts. The degree of this function is 3 and it has 2 x-intercepts. That means the order or multiplicity of one of the x-intercept should be equal to 2. Let's assume its x-intercepts are -2 and 1. The end behavior can be shown as. Now we can join these end behaviors through these x-intercepts. Let's assume the order or the multiplicity of the x-intercept at 1 is 2. So the graph will be turned back at the x-intercept 1. The order or the multiplicity at x-intercept -2 is 1. So the graph will pass straight through the x-intercept at -2. So this can be the graph of function in part B. Now we can answer part C. A quadratic function with a positive leading coefficient and no x-intercept. A quadratic function has a degree equal to 2. The leading coefficient is positive. That means the end behavior for this function should be from quadrant 2 to quadrant 1. This function has no x-intercept. We know that the graph of a quadratic function is a parabola, and this parabola opens upward because the end behavior is from quadrant 2 to quadrant 1. Since there are no x-intercepts, that means the parabola should be above the x-axis. So one such parabola can be drawn as, so this can be the graph for part C. Now we can analyze part D. A quintic function with a negative leading coefficient and 5 x-intercepts. The degree of a quintic function is 5. The leading coefficient is negative. That means the end behavior for this function should be from quadrant 2 to quadrant 4. This function has 5 x-intercepts. The degree of this function is equal to the number of x-intercepts. That means the order or multiplicity for each x-intercept should be 1. The graph should pass straight through the x-intercept. Let's assume the x-intercepts are at -3, -1, 0, 2, and 3. Now we can show the end behavior. Now we can join these end behaviors through these x-intercepts. So this can be the graph of function in part D. So these are the steps we have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.